Hello, this is Charlene. We're going to be converting rational exponents to radical form and vice versa. This gives us a definition of a to the 1 over n power or exponent. It says if the nth root of a represents a real number and n is greater than 2 and it's an integer, then a to the exponent of 1 over n is equal to the nth root of a. Okay, but I wanted to ask you this question. Why does it say that n must be equal to or greater than 2? Well, n is representing the root. So when we have a radical and there's nothing there, it really means that we are talking about the square root. The smallest root that you can find of any number is a square root. There's no such thing as a first root of a number. So that's why they clarify and say that n is greater than or equal to 2, because this is the very first one. Okay, so this says that we are going to use radical notation to rewrite each expression and simplify. So I do need to make you aware that when it says to simplify, our answers may be one of two things in this section. Our answers may be a number. They may be a number. We may simplify it to a number. Or it may be a radical. So a number or a radical, but the radical will be reduced to simplest form. Okay, so let's look at the first one right here. We've got 64 to the 1/2 power, and we have to understand that this top part is the power. Top part is the power, and the bottom denominator is going to be the root. So if it is a root of 2, that means a square root. So that means it's going to be equal to the square root of 64. And of course, a lot of you may already know what the square root of 64 is, but just in case you need a refresher, we're going to break it down into some factors. Well, when I have 8 times 8, 8 times 8 equals 64, and that is a pair of roots, which we're looking for a pair of roots. A square root means we're looking for pairs. So that means that the 8 comes out to represent the pair. So therefore, the final answer here, 64 to the 1/2 power is equal to the square root of 64, which is also equal to 8. Again, we're going to use radical notation to rewrite the expression and then simplify it. So this, again, we have the power is on top. Power is on top, and the root is on the bottom. So that means that instead of the square root, we are actually going to have the third root. So it is the third root or the cube root of the y to the first power. But can we take a third root of a y? Well, can I find any factors of y? No, it's just a single y. It's just one y. So therefore, I can let this 1 go invisible if I want to. So it would just be the cube root of y. And that's as far as I can go. That's as simple as it can go. Our next problem says negative 16 is raised to the 1/4 power. And it is notable the fact that there are parentheses around the negative 16, which means that the power applies to both the 16 and the negative. That is significant. So again, we have on the top in the numerator, we have the power, and on the bottom in the denominator, we have the root, which means that our root is the fourth root. So we can have the fourth root of the entire number of negative 16. However, can we take an even root of a negative number? No, we cannot, because if we have like a negative 4 times a negative 4, that is actually going to give me a positive number. It's going to give me a positive number. So same thing, anytime it's an even root, you cannot take the even root of negative numbers without incurring an imaginary I. So this cannot be simplified further without bringing in a complex number like the imaginary I. Therefore, this is as simple as we can go to put it in radical form. Okay, let's keep going. Okay, so this problem is a little bit similar to the others, the one that we just did. But the thing is, though, there are no parentheses. And this is also significant because that means this power of 1 over 4 is going to apply to the 16, but it will not apply to the negative in front of it. So what we need to do in order to address that -1 is the fact that it is a -1. It's like it's a -1. There's an invisible -1 there, and it's times 16 to the 1/4 power. So we just separate that -1. We can do that because it's not in parentheses, and this 1/4 power is not affecting the -1, the invisible -1 that's right there. Okay, so now we can rewrite that again, -1, and then go ahead and write this to the 4th root. So it's going to be the 4th root of 16. Okay, so in the problem we had before, we had a -16 under the radical. You can't do that, but can I take the 4th root of 16? Well, sure I can. So let's -1. Let's go ahead and rewrite 16 into factors. So 2, well, let's go ahead and start simpler. We'll do an extra step just to make sure it's really clear. So I can do 4 times 4. Everybody knows 4 times 4 is 16. And then I could break it down again. And I can say the -1 times the 4th root. And I could break down 4 and 4 into 2 times 2, 2 times 2 times 2 times 2. Well, guess what we got there? We've got 1, 2, 3, 4. I got 4 factors. If I'm looking for the 4th root, I'm looking for 4 factors. So that means that the 4 twos, 1, 2 can come out to represent the 4th root of 4 factors. So that means that my final answer is going to be -1. 2 is going to come out of the radical. Since I used up all of my factors inside the radical disappears. And I can now do -1 times 2, which is -2. So -16 to the 1/4 power is equal to -2. Our next problem says we have -27 raised to the 1/3 power. And again, significant that it's in parentheses because we are going to have the exponent of 1/3 affect the negative as well. So again, it is going to be the 3rd root of a -27. Well, we cannot take an even root of a negative number, but we can take the odd root of a negative number. For just a moment, though, for simplicity's sake, let's talk about 27 without the negative. And I can break that down into like 9 times 3, and then I can break it down again. 9 can break down into 3 times 3 times 3. Well, because this is a negative, I can do -3 times -3 times -3. 2 of these negatives would cancel each other out, but I would still be left with another negative, which means 3 times 3 is 9 times 3 is 27, and the final answer would be -27. So I can break down this -27 into -3 times -3 times -3. So that's going to be equal to cube root of -3 times -3 times -3, and voila, I'm looking for a cube root, which means I'm looking for 3 of the same factors. I have 3 of the same factors, and so that means that -3 can come out to represent all 3 -3 factors. So that means that if I'm using up all my factors under the radical is going to disappear. So my final answer is going to be just that -3. That is the answer for this -27 in parentheses raised to the 1/3 power. Okay, let's see what the next one is. Okay, so this one says 6x squared y raised to the 1/5. And again, this does affect every single piece inside the parentheses. Anytime we have an exponent outside the parentheses, it will apply to every single piece inside the parentheses. So that means that I'm going to have the 5th root of all of these things, 6x squared and y. Okay, so do I have factors of 6 where I would have 5 of the same factor? No. So I'm going to have to leave that in the house. Do I have at least 5 x's so that I would have 5 factors of x? No. So that's going to have to stay in the house. Do I have 5 factors of y? No, I only have a single y. So that means that our final answer is just the fifth root of 6x squared y. We cannot simplify it anymore. That is as simple as we can simplify it and reduce it. Our next problem says x raised to the 2/3 exponent. And again, the top is going to be our power and the bottom is going to be our root. So that means our root is a cube root of x raised to the second power. Okay, can I take the cube root of x squared? Well, no, I cannot, because that means x squared actually breaks down into 2 x's. That is not enough to take a cube root of it. So therefore, this is as simple as we can go. So that is converting the rational exponent to radical form. Okay, our next problem says 9 to the 2/3 power. Again, we got the root on the bottom and the power on the top. So I'm going to do the cube root of 9 squared. Okay, so we can square 9, right? What's 9 times 9? It's going to be the cube root of 81. Okay, can I take the cube root of 81? Well, I don't know. So let's go up here. I could have actually broken it down into factors just using the 9 squared. So I could have done cube root of 9 times 9, which was 9 times 9, which then that could break down into cube root of 3 times 3 times 3 times 3. Aha! Do I have a cube root? Well, I have 3 of them right there. But guess what? This lonely 3 over here is going to have to stay in the house. But 1 3, this triplet of 3's, this cube root, 1 3 will come out to represent the 3 roots of 3. So that is going to be equal to 3, which comes out of the radical, and it'll be times 3, the cube root of 3, but this 3 has to stay in the house. The last loosey-goosey 3 has to stay in the house. So that means 9 to the 2/3 power is equal to 3 times the cube root of 3. And that is a simplified radical form. Okay, this problem says negative 32 raised to the 4/5 exponent, but this rational exponent does not apply to the -1 because it is not in parentheses. So we are going to separate it out because there's like an invisible 1 right there times that 32. So I'm going to separate it out. So -1 times the 32 raised to the 4/5 power. Okay, and if you've been paying attention to their video, you know that the top one is the power and the numerator is the root. So we are going to rewrite that as -1 and times the fifth root of 32 to the 4th power. Okay, so if I go ahead and do 32 to the 4th power, that's going to be a really big number. So let me tell you something that we are allowed to do. We are allowed to bring that 4 outside of that radical if we want to. So I'm going to rewrite this as -1 times the fifth root of 32 raised to the 4th power, because I can more easily figure out what the fifth root of 32 is. Then if I multiply 32 times 32 times 32 times 32, that's going to be a really gigantic number. That's going to be more difficult to work with. But I can do this right here. So I'm going to look at 32, look at some factor pairs. So I got like 2 times 16 and 2 times 4 times 4, and then 2 times 2 times 2 times 2 times 2. Magically, I have 1, 2, 3, 4, 5 2's, which means I have a fifth root. So that means that the fifth root of 32 is 2. So I can do that. Yay. Okay, so it's going to be -1 times the fifth root of 32. Fifth root of 32, there's 5 of them, so 2 comes out to represent 32. So it's going to be 2. I used up all of my factors, so the radical disappears, but then I'm going to raise it to the fourth power. Now I'm going to raise it to the fourth power, which is much easier, right? So I can do -1 times 2 times 2 times 2 times 2. Do we all agree that 2 to the fourth power is equal to 2 times 2 times 2 times 2? Yes. Okay, so that means that I now have -1. Oop, and I think I forgot my negative right there. -1. -1, and then 2 times 2 is 4, times 2 is 8, times 2 again is 16, so times 16. And so my final answer is going to be -16. So it's always significant that when I've got a negative out here that's not affected by that power, it typically gives me a final answer that's also negative. So -32 to the 4/5 power is equal to -16. Okay, let's see what else we have here. Aha, we have the same question, except now the -32 is in parentheses, which means that that 4/5 is going to also affect the negative. So we're going to go ahead and put the fifth root on the outside. That's the denominator. -32 raised to the fourth power. Okay, so again, if you remember, if we have an odd root, we can take the odd root of a negative number. And from that last problem that we did, we also remember that we can bring this 4 outside here. We can do the raised to the fourth power afterwards. Because if I do -32 times 4, that's going to be a really gigantic number, and it's more difficult to deal with. So I'm going to rewrite this as the fifth root of -32, and then we'll raise the whole thing at the end to the fourth power. I'm allowed to do that. Okay, so again, what is the fifth root of the -32? Well, we actually did figure out all the roots of 32, right? Is 2 times 2 times 2 times 2 times 2, 5 of them. And because it's negative, all of those numbers could also be negative. -2 times -2 times -2 times -2 times -2, because, again, these two negatives would definitely cancel each other out. These two negatives would cancel each other out, but I would still end up with one loosey-goosey negative, which gives me my -32. So that's the reason why you can do odd. You could take the odd roots of negative numbers because there's always one left over. Okay, so that means I can rewrite this as the fifth root of -2 times -2 times -2 times -2 times -2. Right? Did I get 5 of them in there? 1, 2, 3, 4, 5. Yes. And then all of that is going to be, after I get that answer, that'll all be raised to the fourth power. So since I have 1, 2, 3, 4, 5 factors, that means one of those -2's comes out to represent all 5 of them. So that means it's going to be -2, but then -2 is going to be raised to the fourth power. Now, since this is an even power, guess what? All these negatives now are going to cancel each other out, because that technically is -2 times -2 times -2 times -2, which means all the negatives cancels out. 4 of them. 1, 2, 3, and 4. So my final answer is going to be 2 times 2 is 4, times 2 is 8, times 2 is 16. So this one, the -32 in parentheses raised to the 4/5 power, is equal to a positive 16. Okay, now we have -16 raised to the 3/4 exponent, and it is not affecting the negative. So that means we are going to have a -1. We're going to isolate that negative, that invisible -1 that's in front. So -1 times the 16 raised to the 3/4 power. And this is the denominator is the root, the numerator is the power. So we're going to rewrite that as -1 times the fourth root, fourth root of 16 raised to the third power. And again, like we said before, we can take this 3 and actually kind of move it out here and deal with it last. So that's what we're going to do here. We're going to do -1 times the fourth root of 16. And then lastly, we will deal with that power of 3. So again, I want to break down 16 into factors. So I got like 2 times 8 and 2 times 2 times 4 and 2 times 2 times 2 times 2. Aha! 16 has 4 roots of 2, and we're looking for a fourth root. So we are in business. So that means it's going to be -1 times the fourth root of 16. So like the fourth root of 16 is going to be equal to those 4 2's, 2 times 2 times 2 times 2. So all 4 are represented by 1 2 that comes out of the radical. Since I'm using up all my factors, my radical is going to disappear. So that's going to end up being 2. But then we've got to not forget to raise it to the third power. So that means it's going to be equal to -1. What's 2 raised to the third power? 2 times 2 times 2. Well, that's going to be 8. So my final answer is going to be -8. So -16 raised to the 3/4 power, and it's not in parentheses, is going to give me an answer of -8. Okay. Now we're going to the next section, which is going to go in the opposite direction. We've been going from rational exponents to radicals. Now we're going to start with a radical, and we're going to turn it into its form with a rational exponent. So again, if we have no number here, it actually means the square root, right? And if I have no number up here, it's invisible. It's the invisible 1. So that means I can change this into 13AB because all of it's under the radical. So that means that it's all stuck together. And I can raise it to the power of 1 and the root of 2. And that's all you'd have to do. That's the answer. If we want to convert it from the radical form to a form where it has a rational exponent, that's it. It's pretty simple, right? Okay, let's go to the next one. Okay, so again, here's my root, here's my power, and so it's going to be 7 is going to be raised to a power over a root. So a power over a root. So that's going to be 7 raised to the power of 5 over the root of 3. And that's the final conversion. Okay. And I think we've got one last problem here. Again, this is my root right here. This is my power. So I'm going to change that to 13xy because 13xy, all of that is under the radical. So it's all kind of stuck together. And then I'm going to raise it to the power over the root. So that's going to be equal to 13xy. And I do want to put that in parentheses. Let's put that in parentheses. All of that, because it was all under the radical. So it all needs to be in parentheses because the root affected everything, and this power affected everything. So let's put it in parentheses. My power is 9, and my root is 4. And now I am finished. That is the conversion from the radical form to a rational exponent. Okay, so hopefully this video has been helpful to help you think about how to go through these processes and maybe a few hints that makes it a little bit easier for you. So y'all just have a great day, okay? This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.